Hey guys, and welcome to 7.2's lesson on proving angles that are parallel. So we have got two learning targets. One of them is to develop theorems to show that lines are parallel, and the second one is to determine whether lines are parallel or not. We did a little bit of this in our last activity, determining whether congruent symbols or numbers meant the lines were parallel, but we're going to look at some proofs today. So, make use of structure. We're going to state the converse of each postulate. And so a converse of the statement if P then Q is going to be if Q then P. So basically I'm reversing it. So if Miss Callahan is a teacher, then I don't know. That's a terrible example. But a converse is the opposite. So we're going to look at the same side interior angles theorem. So I'm going to go back to our lesson on 7.1, which we said if two parallel lines are cut by a transversal, then the same side interior angles are supplementary, meaning 180. So that is the normal way. We're going to do the converse, which means we're going to flip it. So what that looks like, it says if the same side interior angles are supplementary when two lines are cut by a transversal, then I know the two lines are parallel. So I took the definition if two lines are parallel and cut by a transversal then, and I flipped it around. So a hint is then the two lines are parallel is going to be at the end of all my statements. Okay, so I'm just working backwards. So again, the same side interior angles theorem, the converse is if same side interior angles are supplementary when two lines are cut by a transversal, then the two lines are parallel. Okay? So I want you guys to try B and C. You're going to be writing the converse again, so it's going to follow this similar statement. Maybe you wouldn't have supplementary, maybe you would have congruent, but try B and C. And if you need to look back at your 7.1 notes, feel free to do that. So press pause and try B and C. So hopefully you saw that the when two lines are cut by a transversal, then the two lines are parallel is the same in both of your following things. The only thing that's going to be different is on part B if alternate interior angles are congruent, so they're not supplementary. So the converse would be if alternate interior angles are congruent when two lines are cut by a transversal, then I know the two lines are parallel. Same thing for C, corresponding. We know corresponding angles are congruent. So if the corresponding angles are congruent when two lines are cut by a transversal, then I know the two lines are parallel. Okay, so it's just kind of working backwards off of what we did yesterday. If you have any questions on how to write the converse, please let me know. Otherwise, we're going to take a look at some proofs. So from yesterday, here's kind of what our proofs looked like. I was given that they were parallel, and I wanted to prove congruence. So let's take a look at this first one. First off, I'm going to put my givens as first. So M, that is not the right one I want to use. So M is parallel to N, and the reason would be that is given. And then remember our proof part always goes bottom left, so angle 4 is congruent to angle 6. So now let's fill in this part right here. So if they're parallel, this says that angle 4 is congruent to angle 2. Here's angle 4, here's angle 2. The reason they're congruent is, well, they're vertical angles, and so that would be the vertical angles theorem. Okay. Then it says I know 2 is congruent to 6. So 2, I'm going to change it to a blue color, and then 6. I know they're congruent because they're corresponding angles, so that'd be the corresponding angle postulate. And then last but not least, 4 and 6, they are alternate interior angles, but the reason they are congruent, I gotta put all this together. So it says if 4 is congruent to 2 and 2 is congruent to 6, then 4 is congruent to 6. So that's kind of the transitive property. Okay, so that is what we learned in our previous lesson. We were given something that was parallel and we were trying to prove congruence. Okay, what we're doing today, this looks a little bit different. So it says complete the converse, so I'm dealing with the converse. And then notice over here I was given they were parallel. Over here I am proving they are parallel. So from yesterday, I was given they were parallel and I proved congruence. Now we're going to work backwards. So if they're congruent, I'm going to prove they're parallel. And that is the key word for converse. Okay? All right, so let's take a look at this first one. Complete the following proof of the converse of the corresponding angles postulate. So given 1 is congruent to 5, let's go ahead and write our given. And that is given. Again, the proof part is always going to go bottom left, so M is parallel to N. Now I just kind of have to figure this part out. So number 1, what happened between 1 and 2? It says 1 is congruent to 5, the measure of 1 equals the measure of 5. So the only thing that changed was the congruent went away and they added the M's. And so remember, that's the definition of congruent angles. So definition of congruent angles. So I had to abbreviate to kind of save some space. All right, number 3 says angle 1, which is up here, plus angle 4 is going to equal 180, and that is because of the linear pair postulate, which makes sense. Number 4 says 5, down here in green, plus 4 is equal to 180. Okay, so is there a vocab word for 5 and 4 that we already know? Yes. It is the same side interior postulate, but the only thing that happened from 3 to 4 is the 4s stayed the same, the 180 stayed the same, and this 1 magically became a 5, and that was because we know 1 is the same as 5. So they substituted that 5 in place of that 1, so that's a substitution property. Okay. Forgot to put the word property. All right, and then the difference between 4 and 5, so I know the measure of angle 5 plus the measure of angle 4 is 180. Then it says angle 5 and angle 4 are supplementary. So the reason if they're 180 they're supplementary is that's the definition of what supplementary angles are. So definition of supplementary angles. So again, I had to abbreviate, okay? But then I know that M and N are going to be parallel, okay? And that will be the converse of the same side interior angles theorem, okay? Because 5 and 4 are same side interior angles. Converse because I proved parallel, okay? So if you're ever proving parallel, you will have the word converse probably in your proof, okay? So that's a little bit of what we did yesterday versus today. So again, converse is just working backwards. So given congruence or given something true, prove that they are parallel. Okay? All right, if you have any questions on proofs of converse theorems, please let me know. Otherwise, you guys are going to try the entire back page on your own and then press pause and we will go over all of the answers. Okay? So try your best if you need to skip around. So if you think you can do number 12 and 13 and 14, great. If 15 confuses you, skip it and do as much as you can, and then we'll go over the answers. So press pause. Good luck. Let's go over these answers. So on number 12, it says given that 1 is 52 and then 7 is 52, are they parallel? So 1 and 7 are alternate exterior angles, and we know that they're congruent. So 52 equals 52, so therefore it is true. So number 12 was yes. 1 and 7 are alternate exterior, therefore I know that line M is parallel to line P. Number 13 is going to be a no because 11 and 3, 11 would be here, 3 would be here, they are alternating on the inside of line M and line N, and therefore they should be the same because we know alternate interior angles should be congruent, and they're not, so it's not parallel. Number 14 is going to be no, so number 14 gives you 10, and then 7. So technically there is no vocabulary word for 10 and 7, but I do know I'm allowed to move them closer to each other. So if these lines were parallel, I could move 7 here in place of 9, because it's corresponding. So then I would take a look at the relationship between a 9 and a 10. I would expect them to add to 180 degrees because they're a linear pair, and they should be supplementary. But if you add 124 and 52, you only get 176, which is not going to get you to 180 degrees. Therefore, they are not going to be parallel. Okay? So again, to be parallel, they're either going to be congruent or they're going to add up to 180 and be supplementary. Okay? If you have any questions on that, let me know. Number 15 says, two lines are cut by a transversal such that a pair of alternate interior angles are right angles. Are the two lines parallel? Explain. So yes, because all right angles are congruent, and therefore if they're alternate interior angles, they should also be congruent, meaning the lines are parallel. Okay? So if you need a picture to see that, parallel lines cut by a transversal, it's going to be perpendicular, and so if the alternate interior are 90, that works out because they are congruent. It also works out because same side interior add up to 180. Okay? All right, 16 says if A is parallel to B and B is parallel to C, can you conclude that A is parallel to C? So this is kind of like the transitive property. If A is parallel to B and B is parallel to C, is A parallel to C? The answer is yes. And so here's a picture. You have three lines that are all parallel to each other based on the transitive property. Okay? So as long as you said something along the lines of yes, because of the transitive property, it can prove they're parallel. If you have any questions on that one, please let me know. Feel free to press pause to write this down. All right, number 17. Determine the order of the proof. So here are the answers. So one was a given. The second one was the measure of 4 equals the measure of 6. The only thing that changed between that was the congruent and the equal symbol, so definition of congruent angles. The linear pair postulate says angle 5 plus angle 6 is 180. The only thing that happened between 3 and 4, they kept 5, they kept 180, they substituted 6 in for 4. So that'd be the substitution property. Number 4, if they are equal to 180, I know they're supplementary because that's the definition of supplementary. And then last but not least, that would be the same side interior angles theorem because 4 and 5 are same side interior angles. It's the converse because I proved parallel. Okay? Let me know if you have any questions on the proof part. All right, 13. If 2 is 110 and 3 is 80, are they parallel? No. So 2 and 3 are same side interior angles. I would expect them to be supplementary, but they instead add to 190, which is not good, so they're not parallel. 14, if 8 is congruent to 4, are they parallel? So yes, we know alternate exterior angles should be congruent, so if they're congruent, then my lines are parallel. Last but not least, 5 and 7, what's the value of x for them to be parallel? So 5 is an exterior angle, 7 is down here, it's a corresponding angle. We know corresponding angles are congruent, so you would set the equations equal to each other, you would solve and get x is 6. So x being 6 would make the lines parallel. Okay? If you have any questions on those, please let me know. Feel free to go back and rewatch if I did speak too fast. Otherwise, you are ready to practice, and thanks for watching.